Okay, so now that we've talked about general synovial joint structure, both the structures you find there and the accessory structures, we've then talked about how these synovial joints move, okay, what types of motions are possible. Now it turns out that we can further subclassify synovial joints into different sorts of shapes. Not all the bones in a synovial joint, they don't always fit together the same in every single joint. And that's part of what makes the different motions possible at each of the joints. So here are the 6 categories right here of the different types of shapes, okay? And the first one is going to be a gliding joint. Not surprisingly, gliding joints are going to be capable of gliding movements. And so, for example, we have our foot again with the tarsals. And these are capable of gliding movements, and so the shapes of the bones are going to allow that slight gliding past each other. Okay. The next type of joint is going to be a hinge joint, and it's going to look similar to the hinge on a door. And so let me show you what that will look like. Okay, so here we've got the humerus and connected to the ulna. Okay, and you'll notice how it just goes past each other like that. Okay. Now this is pretty much like a hinge on a door. It's going to allow this sort of movement, but only in one direction. So hinge joints typically only allow monoaxial movement, meaning movement in only one plane. You can't move it side to side, right? You can't move it in that direction, or you couldn't sit there and try and move it like this. Okay, it's just one plane, one direction. Okay. The next one is going to be condylar joints, and I believe your book may call it condylar, and then your textbook or your lab manual, I believe, calls it ellipsoid. So ellipsoid and condylar mean the same thing. Okay, so these joints, basically what they are going to look like is that one has an oval surface, and that is going to sit in another bone that matches that. Okay, so again, let me bring up the foot. Okay, so phalanges is going to be an example of condylar. So this joint right in there, one surface here is going to be oval, the other has a depression, and so it's going to move in that way. Okay, it can allow movement in biaxial, so in 2 different planes. And so if we go over here on our notes packets and we're filling in, and again, if you're looking on these right here, if it's synovial, it's going to tell you, for example, here's a synovial hinge. Okay, so the ulna with the humerus, so that's a hinge joint, and it's going to tell you the type of movements. Okay, so again, you can go through here to look for what is a hinge joint, what is a pivot joint, what is a gliding joint, these different things. Your text or your lab manual calls gliding joints plane joints, so plane equals the same thing as gliding. Okay, and to give you another look here, okay, we've got saddle joints, and this is going to fit together like a rider and a saddle. So here would be my saddle like this, and the rider is going to fit over it like that. What's different between condylar and saddle joints, condylar is more like this, okay, and saddle is going to be where they hang over each other like that. A saddle joint, the best location to see that is actually in your hand. This is your very first, this right here is your very first metacarpal, okay? And it's going to attach to a carpal right in this location. And so that joint right there, okay, is going to be a saddle joint. Pivot joints allow rotational movement, and so they allow one bone to rotate around another part of the other bone. And so some examples of pivot joints, we've already talked about that, but let me show you a couple of examples. So here's the radius in the ulna, and so notice the pivoting that can happen there. Okay. The other pivot joint that we see is going to be with the first two vertebrae. Okay. And so here is atlas and axis, and notice the rotation, the pivot that occurs around the dens. Okay. Then the last type of shape that you're going to see is going to be a ball and a socket joint. Okay, and this is where you have a large rounded head that fits in the depression of another bone. And the big difference between this versus condylar, the bone surfaces are a little bit more restricted, so you're only getting biaxial movements. But ball and socket joints, they're going to allow multi-axial movements, including circumduction. So an example of that is going to be the hip joint is one, the shoulder joint is another, but here is the femur head, here is your os coxa, and you're going to notice they fit together. Okay, so this is like the ball and the socket over here, and so that's what's going to allow this multi-axial circumduction at this joint. Okay, and so here are some further videos and some exercises to help you practice classifying. Again, I really do want to point you to this resource on page 170 and 171 of your lab manual, because this really helps give you a sense of what joints are out there, how they move, and then the notes are just a different way of trying to take that same information and put it here so that you understand the shape classifications of synovial joints, and also here so that you know how these different joints move. Okay. All right.